The next function we're going to look at is called a piecewise function, and this is going to so far take each of the different types of functions that we have looked at, so absolute value and linear, and put them into one graph. So what do I mean by that? A piecewise function is looking at least two, could be 3, 4, 5 equations that only go for a specific part of a domain. So that means we're breaking a function into pieces. Okay, so how we write that, we're going to use our function notation, f of x is equal to, and then we use a bracket here to represent each of the pieces of the function. So that means for all x values that I use that are bigger than 0, the graph y equals x will be the picture for that part of the graph. Next, when x equals 0, I have y equals 0, and when x is less than 0, I graph the graph negative x, y equals negative x. So let's go through and look at a few of these, look at how the steps and everything go for making a graph, and practice making these pictures. So first we're going to sketch the boundary lines. Usually what I do is I look at the x values in my inequality pieces, and then I'm going to look at the points, plugging in each of those x values, and then connect the dots. So what do I mean by that? Let's look at the first one. F of x is equal to, for all values bigger than x, I use the graph 3x. So I'm looking at x equals 0. So my boundary is the y-axis. So I'm going to plug in the point 0 and get out. So I'm going to do 3 times 0 equals 0. So I have the point 0, 0. Now, since this inequality is strictly greater than, I'm going to make that an open circle. And then I'm going to use the slope. So this is for all the values greater than 0, so that's everything on this side of the graph. Okay, so I'm going to use the slope of 3, and I'm going to go up 1, 2, 3, and over 1, and connect the dots. So we're going to pretend that's a line. That should be straight. And that part of the graph looks like that. The other half of the graph, for all the values less than or equal to 0, I get the graph y equals negative 2. So if I plug in 0 here, I'm going to get out negative 2. And since it's less than or equal, that's a closed circle. And y equals 2 is a horizontal line, so for everything less than 0, I'm going to graph the horizontal line, y equals negative 2. So what we have now is a graph that is in two pieces. Let's look at the next one. So I'm going to graph y equals 2x minus 1 for all of the x values that are less than 0. So 0 being my boundary, so I'm going to plug in 0. If I plug in 0, I get out negative 1. And it's going to be an open circle because this is strictly less than. So I'm going to graph the point 0, negative 1. Now this line should have a slope of 2. So what that means is, since I want all the values to the left, instead of going up 2 and to the right 1, I'm going to go down 2 and to the left 1 because I want to go to the left. Okay, so that's the one half of the graph. The other half is going to be using 2x plus 3. So again, I'm going to plug 0 in, and I get out 3. So I'm going to plot the point 0, 3. Because it's got the or equals to, I'm going to make it a closed circle. Now since I am going to the right, I'm going to use the slope of 2 and go up 2 and to the right 1. And there's my graph. So I have broken it up into two pieces. Let's do one more before I send you off to try one. Alright, so I've got the equation f of x is equal to x minus 4 for all values less than 3. So if I plug in 3, I get out negative 1, and that's going to be an open circle there because it's strictly less than. And now since this has a slope of 1 and I want all the values to the left of 3, I'm going to go down 1 and to the right 1, or excuse me, down 1 and to the left 1 so that I can get my positive slope of 1. Sorry, these lines aren't coming out very straight. And then for the other half, if I plug in 3, I'm going to get out negative 1. It's a horizontal line, and it's going to be closed in because it's greater than or equal to 3. So that's actually going to fill in this hole, and then go horizontal. That's actually a pretty straight line. What I want you to do now is I want you to try graphing this one. Okay, so the first half, for all values strictly greater than 0, use the line x plus 2. And for all values less than or equal to 0, graph the negative 2/3 x plus 3. Alright, so let's hope your graph looks the same as mine. So I'm going to have the point 0, 2 open, and all the values bigger has a slope of 1. And then if I plug in 0 here, I should get out 3, and that'll be closed. And it's supposed to have a negative slope, so instead of going up, down 2 and to the right 3, I'm going to go up 2 and to the left 3. 1, 2, 1, 2, 3. So I should get a graph that looks like that. Okay, try number 5 for yourself. All right, number 6, I'm going to have a horizontal line at y equals 6 for all of the values less than negative 2. So I've got, and it's going to be open circle, all the values less than, whoops, so I've got negative 2, 6. So all the values less than negative 2 will equal to 6. And all the values greater than negative 2 or equal to it, I get negative 2, negative 3, so I'm going to have the closed circle there. So my 2 halves should look something like that. So now each of these have been 2 graphs. What happens when I have 3? Okay, so I'm going to have to do this several times. So I'm going to go ahead and break this into 3 pieces. 1, 2, 3. And the middle one, I'm going to have to use 2 points because it's going to have end points. Okay, instead of just like in our last one, an arrow pointing in each direction, we're going to piece. So first I'm going to graph y equals 4 for all values greater than 3. So I'm going to plot the point 3, 4 with an open circle. And all the values bigger than 3 are going to be y equals 4. So there's my horizontal line. Now for the middle one, if I plug in negative 1, I get out 1. And if I plug in 3, I get out 1. So I'm going to plot those 2 points, and notice both of them have the or equals to underneath them. So they're both going to be closed circles. And then I can just connect the dots. And last but not least, I've got, if I plug in negative 1, I get out negative 3. It'll be open because it's strictly less than, and all the values less than that are going to be on that horizontal line. Okay, let's change up the ante a little bit and make the middle equation actually a little more cumbersome. So if I start on the right side, I'm going to plot the point 4, 5 with an open circle. And all the values bigger than 4 will equal 5, so I've got a horizontal line. Now this one, I'm going to come down here. If I plug in negative 2, negative of negative 2 is positive 2. Then I also need to plug in the 4. Negative of 4 is negative 4. Both of these, since they're both less than or equal to, I'm going to have closed circles. So I'm going to have negative 2, 2, and 4, 1, 2, 3, negative 4. And I can connect the dots because it's linear. And last but not least, the left side, which is going to be the point at negative 2, 4 with an open circle, and it's a horizontal line for all the values smaller. Alright, so if one of the equations in my piecewise function is not linear. So looking at absolute value of x. I know absolute value of x is that v. And this particular one has a vertex at 0, 0, which happens to fall within the interval that's given here. So I need to keep that in mind when I draw my picture. So for the top function, I'm going to plug in the 2. Oops, sorry. Let me come down here. This is not cooperating with me. So I've got 2, 4, and it's going to be an open circle. and it's a horizontal line for all those values bigger than 2. And then from negative 2 to 2, it's the absolute value of x. So if I plug in negative 2, absolute value of negative 2 is 2. And if I also plug in positive 2, I also get out 2. And those are both or equal to, so I've got to have closed circles there. But I also know that the vertex is going to happen at 0, 0. So I can't just draw straight across and make it a horizontal line. I need to show that this is the part of the V that I have. And last but not least, I've got negative 2 comma 4 with an open circle, since it's strictly less than negative 2, and all the values less than negative 2 are equal to 4 in this case. So this one, you have to be careful. The only time, if you have an equation that is not linear, you can't just connect the two endpoint dots. This one has the vertex of this absolute value happening between, so I had to make that part of the V.